everybody. So I wanted to wrap up section 4.2 so that we don't lose any time. We lost that Thursday. So I want to finish this section up so you can finish that oh wow. I was working on this earlier, so I'm kind of covering up my answers as we go through. So let's, this is the section 4.2. We're going to make two short videos to finish up this section. One that will get us through rules of divisibility, and then the other one to get us through prime numbers. All right, so for this first one, it looks like we got it right up to the division in number sense. And so let's look at this first one. It says, I'm thinking of a number that has a remainder of 5 when divided by 16. All right, so let's at least set it up. I'm thinking of a number that has a remainder of 5. Turn the lamp on. A remainder of 5 when divided by 16. And we're looking for this number right here. Okay? I'm thinking of a number that has a remainder of 5 when we divide it by 16. Okay, so do you guys remember, why that lamp looks a little wonky, maybe it's not as wonky as I think, when you were younger and you said like 25 divided by 4, you said was 6, remainder 1, right? And then to check it, you would go 6 times 4 is 24 plus 1, and that would give you the dividend. All right, well that's the same thing that's going to go along here, okay? So we're going to figure out some number times 16 plus 5 to give us x. So you get to pick what you want the quotient to be. So if you want the quotient to be 1, then it would be 16 times 1 is 16 plus 5 is 21. Like you get to choose. You get to choose what it is. So 21 could be a possible answer. But let's say someone else said, hey, Desiree said, I don't want my quotient to be 1. Desiree says, I want it to be 2. Well, then you're going to have 2 times 16, which is 32, plus 5. Right? So 37 would be a possible answer. Okay? So basically, you just want some multiple of 16, whether it's 2 or 1 or 10, right? Some multiple of 16 that you add 5 to. So that would be 165. Okay? So here I did some work. You can look at what I was playing with earlier. So this right here is supposed to go on the top of the next page. So this is technically the 85 remainder 17 is supposed to go right up there. I don't know why it got copied wonky, but that's where it was supposed to go. So take a pause and see if you can figure out what x should be, right? It's 85 times 56 plus 17. See how you do on it. Okay, did you guys get 4,777? Hopefully that makes some sense. Okay, let's look at this next one. Okay, trying to cover up my answer. So they said find the divisor. So you want some number times 65 plus 5 to equal 785. So here I have it written down here. So I have 65 times some number plus 5 equals 785. Right? I feel like that lamp looks wonky. Is that better? All right, so I'm going to subtract 5 from both sides. Right? So that'll give us 65x equals 780. And then I'm going to divide by 85, or I'm sorry, 65. And then you should get an answer of 12. Okay, so why don't you pause the video and see if you can do this one right here. I put the X in. What is the, and you can tell that I pulled this out of the book or out of WebAssign. What is the value of the divisor that makes this division problem true? So go ahead, give it a try. Pause the video if you need to, because I'm going to show it to you if you're not done. So did you get 11 times x plus the remainder equals 463, and then I popped the remainder in. So 11 times x plus 1 equals 463. We're going to subtract 1 from both sides. Cover up the answer here. Subtract 1 from both sides. Okay, and then we're going to divide by 11. So did you guys end up getting x equals 42? And then I thought these ones were kind of interesting too. I'm trying to hide the answers. I thought I had 2 copies of this, but I don't. So it says, how many buses are needed if each bus can take 25 passengers and there are 334 students? Well, how many groups of 25 can you get out of 334? And that'll tell you how many buses. So how many groups, how many 25s can you get out of there? So this I thought was an interesting problem, because again, this is under number sense for kids, okay? This is number sense. So a lot of kids are tempted to say 13 because they're so used to rounding down, right? But if you take 13 times 25, that's only 325 students, and we need 334. So this is a concept of number sense where the students have to round up and go against that rule of rounding, right? So I thought that was an interesting homework problem. And so this says, how many buses are needed if we place 2 adults on the bus? So if you place 2 adults on each bus, then now the buses can only take 23 kids. So how many groups of 23 can we get out of 334? So it looks like 14.5 groups, but again, we have to think about 14 buses isn't enough buses. So this is one where we have to round up to get the correct number of buses. So we would need 15 buses. All right, this was one right out of the book. Why don't you give it a try? Pause the video. Give it a try, pause it, and see what you can make of it. So if you're thinking of a number that has a remainder of 16 when divided by 75, I just picked the most basic ones. I let my quotient be 1. So 1 times 75 plus 16 is 91. So 91 is one of my answers. But if someone said, hey, I don't want my quotient to be 1, I want my quotient, Peg says, I want my quotient to be 2, then you'll take 2 times 75 plus 16. And so one of your answers will be 166. And there's an infinite number of answers, so those are just 2 of the the most basic, simple ones. All right, and then the last page that I actually have work already written on is this page. Now, I just wanted to show you, I thought this was interesting. I remember learning when you multiply or divide by powers of 10 that you shift the decimal. So if you multiply by 10, you shift the decimal 1 place to the right. Or if you multiply by 100, you shift the decimal 2 places to the right. So I found this interesting because actually Engage New York is actually doing a good job with this, because it's really not the decimal point that shifts. It's the value of the number. So if you multiply 367 times 10, right, this is what's happening. So this is what the product is. So do you see the value of the place value of the numbers all got shifted? The 7 got shifted from a 1 to a 10. The 6 got shifted from a 10 to 100. And the 3 got shifted from 100 to 1,000. So it's not the decimal that gets shifted. It's the place values of the numbers. So I just found that interesting when I was looking the other day. I'm like, oh, that's kind of cool. They're not doing a decimal shift like I was taught. They're saying the numbers get shifted. So same with division, right? If you divide 300 by 10, that 3 in the hundreds position becomes a 3 in the tens position. It becomes 30-something, right? If you divide 60 by 10, the 60, the 6 that was in the tens position all of a sudden becomes in the ones position. So I just thought that was interesting. I was always taught to shift the decimal, but Engage New York is telling them, the kids, hey, it's not the decimal that gets moved, it's the place value of the number that gets moved. And so when I saw that was a 5th grade paper, I'm like, oh, that's really interesting. That's actually pretty cool. All right, my last little bit, before we hit some PEMDAS and some rules of divisibility, is what's called the scaffolding algorithm. And this is an algorithm that I actually taught my son when he was in 5th grade, because Joey was the famous underguesser. And so it was really frustrating for Joey when he would do a division problem and then he would check it, like 699 times 6 plus 162. Like if you do that on your calculator, it would appear that you did it correctly, right? If the kids are taught, you take the quotient times the divisor and add the remainder, and if that gives you the dividend, you did the division right. So according to Joey, he was getting the division right, but then he kept getting them wrong because he was underguessing. He was the famous underguesser. And so his remainders were too big. But I'm telling you, it can be frustrating if you're a 5th grader, thinking you did it right because you checked it and you're getting it wrong. So what I told Joey is, all right, you are going to underguess and you're going to do it on purpose. I worked it out, but I'm going to work it out so that you can see what I would tell Joey. All right, I'm going to do it again. So I told Joey, start at 1,000, and then you go like by 50, hundreds, 50s, 10s, 1s. And you'll see what I mean in a second. All right. So let's look at this problem. And I would say, okay, Joey, can I use 1,000? So what times 6 gets us the closest to this number, but we're not going to go over. So would 1,000 work? And Joey would say, no, 1,000 times 6 goes over. I say, okay, then we'll start at 500. So will 500 work? So 500 times 6 is 30 with 2 zeros. So he would say, yes, 500 works. And then we subtract. And the cool thing about this is the multiplication's really easy and the subtraction can be really easy because there's so many zeros. And then Joey would see that, again, you can't get another 500. So then I would say you start with hundreds. So what times 6 gets you the closest to 1,356 without going over? Now I want you to use 100. And he'll see that 100 doesn't go over if we say 100 times 6. Okay, and I would say, Joey, can you do another 100? Will another 100 work? He'll say, yeah, another 100 will work, right? Because that's 600, and if I subtract, we get 156. But he would say, I can't do another 100. I would say, okay, can you do 50? He'd say, no, 50 won't work. So now I say, start with some 10s. So he would start with a 10. 10 times 6 is 60. You do another 10, and now he's down to 1s, so then it would just be a 6, and there's no remainder. And so then your quotient is just this scaffold. That's why it's called the scaffolding. You just add this up, 5, 6, 726. And there you go. It's for the underguessers, okay? That's the key thing. If you've got some underguessers, this works. And it doesn't, this could be a 6 or 10 or 15, it doesn't matter what this number is. It's the same concept. All right, so let's try one. Let's try another one. Get some scrap it paper, if I can find a piece of scrap. Yeah, we'll do it on this one. You ready? All right, let's just try a basic one. How about, you got to start it pretty low in your paper because you're going to build the scaffold up. Let's try, I wrote one down earlier, 7,848 divided by 9. And I always tell Joey, start with 1,000, but I should have picked one that was bigger, and then go from there. So 1,000 won't work because 9,000 is going to be too big. So then I would say start with 500. So 9 times 500 is 45 with 2 zeros. See, now I feel like that's too dark. I can't decide whether I need that lamp or not. Okay, and then you subtract. And then I would say, could another 500 work? And he'd say no. So then we'll go to 100. So 900. So that looks like 2448. And I'd say, yep, another 100 will work. So minus 900. Okay, and it looks like we can still get another 100 out of there. So 900. Right? And then I'd say, okay, you're done with that, so let's try 50s. So then he'd go with a 50. He knows he couldn't get another 50, so then I would go with a 10. And then another 10. And then you're down to your singles. And there's no remainder. And then your quotient is the scaffold. So 5, 6, 7, 800, 50, 60, 70, 2. Isn't that cool? It's called the scaffolding algorithm, and I love it for kids that are underguessers, because it's for them. It's for those kids that underguess. Right? You have one on your wow. I would try it like this. Don't take any shortcuts. Pretend you're in 5th grade as an underguesser and go through the thousands, the 500, the hundreds, the 50s. And it's kind of a neat algorithm. I like how it works. All right, and then the last little thing before we get into our rules for divisibility is PEMDAS. And I tell you, PEMDAS is worth covering. The trips that I see for PEMDAS, I'm going to show you because PEMDAS definitely is a little misleading. So this is all about operation sense, right? And it's very, very important for kids to get this down. I have calculus students that still forget their PEMDAS. Let me write down what the reviews, let me write down what PEMDAS means. And when I teach it, believe it or not, I teach it as PEDMASA, because everyone is so used to PEMDAS, and there's a problem with that, with everyone being so used to PEMDAS. And here's the problem. When people look at this, because they're so used to PEMDAS, they're going to flirt with multiplication first. They're going to go, oh, I've got to multiply because of PEMDAS, because the M comes before the D. But the M and the D should be on the same level, like this. So here, and the P, I actually say Gedmaza, because the P really should be grouping symbols. I know people say it's parentheses, but it really is any grouping symbols. Okay. So sometimes I do, instead of PEMDAS, I'll say GEMDAS, or I'll say GEDMASA, just so they break away from that PEMDAS. So grouping symbols. And anything like this can be grouping symbols, absolute values can be grouping symbols, square root is a grouping symbol. It's anything where you have groups of numbers inside it. E stands for exponents. Okay, and then absolutely, I'll write division first. So you're going to divide or multiply in order from left to right. It's whatever comes first. So multiplication is not cooler than division just because it comes first in PEMDAS. Okay? You do what comes first. And then this one too. So you're going to subtract or add in order from left to right. Whatever comes first. Okay? So for this one, you're not allowed to flirt with multiplication because you've got division, right? So you're not allowed to flirt with multiplication. You're going to divide first. So this is going to be 3 times 3, which is 9. Otherwise, if you multiplied first, you would have said 12 divided by 12, which is 1, and that's not right. So for this, you're going to go from left to right. So I'm going to multiply, ignore that division, or that subtraction, because I have a division that I must do first. And then you can go ahead and subtract. So this right here is from my daughter's 6th grade homework. And so it was a whole worksheet. I just picked a couple. There was a whole worksheet where she had to insert at least one set of parentheses so that the expression would evaluate to something other than what it normally would. So, for example, this one without parentheses would be 14 minus 15, or negative 1. Okay? But if you insert parentheses in here, now you're going to get 2 times 2, which is 4, 4 times 3, which is 12. So she had a whole worksheet where she had to insert parentheses in order to have these evaluate to something other than they normally would without the parentheses. I kind of wish I had done these now before I started the video. I'm not going to lie. I think they're hard, and I can't remember what the answers were. So you pause the video. I'm going to look at these and stare at these a while until I can figure them out. And then we'll come back and see how we do. Okay? So pause it, and then come back and join me, and we'll see if we could get them. You might need more than one set of parentheses. I'm not sure. I can't remember. So give it a try. Okay, so I'm staring at this one. Normally we would multiply first, right? But we want to be able to have this evaluate to 28. So let's see, where did you guys insert the parentheses so that it would equal the 28? Well, you don't want them around these because that would give you, right, that would give you 18, and that already is equal to 18, right? So I'm thinking, like, to get 28, it would be 4 times 7, maybe. I'm staring at this. If I put it here, there's not 4 times 7. I can see this now. Here's 5 times 6. There it is. There's 5 times 6. Because you'd have to do the parentheses first. And then you would do the multiplication. So that would be 30 minus 2 is equal to 28. Whew, okay, we got 1. And now we want to put parentheses so that the same thing evaluates to 20. The same expression. So I'm looking at this, and because I saw the 5 earlier. So if we put a set of parentheses there, that's 5. And then if we put a set of parentheses there, that would be 4, and 5 times 4 evaluates to 20. All right, we got 2 done. Whoo, this one looks trickier. All right, let's see. 24 divided by 6 is 4. I think I see it. So if I put this here, this will be 24 divided by 6 plus 2 times 5. So we're going to divide here. So 24 divided by 6 is 4 plus 10. Oop. And that'll equal our 14. They're hard. It's hard. I thought this was a hard exercise, but it was really nice, right? It's a nice example of this kind of operation sense and really understanding what PEMDAS is. Tricky. Okay, the last little bit. I'm going to end the video after these rules of divisibility, and then I'll start the next worksheet or next video with some examples, and then, oh, it just seems dark. Oh, but that seems so bright. And then we'll end it with figuring out what prime numbers are. I just can't tell. I cannot tell. I'm not going to lie. I don't know if that's too bright or not. It's dark outside, so we're not getting any natural light on this. I don't know. I can't tell. All right, you ready, guys? All right. Rules of divisibility. Definitely be on your third test, and definitely will be on the final. A number is divisible by 2. If the number is even. And this is where I really wish we were together. I'd ask you, what does it mean to be even? Like, how can you tell if a number is even? And a number is even. It's interesting to hear what your answers are. And if the number ends with a 0, 2, 4, 6, or 8. Okay? A number is divisible by 5. A number is divisible by 5 if the number ends with a 0 or 5. I think maybe you guys knew these ones. And then a number is divisible by 10 if the number ends with a 0. It's important for kids to know these rules for divisibility when they have to start making tree diagrams with fractions and finding least common denominators. It's pretty popular, greatest common factor. So tree diagrams are important, and so in order to know what branches you can deal with, you need to understand your rules of divisibility. So divisibility by 3 is a cool one. So a number is divisible by 3 if the sum of the number's digits is divisible by 3. Some people like to say, or the sum is a multiple of 3, however you want to think about it. So here, let me give you some real basic ones. You ready? I'm just going to give you a couple 3-digit numbers. So we have 1, 1, 0, 1, 1, 1, 1, 1, 1, 3. I say, which of these is divisible by 3? Well, if I add up these digits, the sum is equal to 2. 3 doesn't go into 2. If I add up these digits, 1 plus 1 plus 1, well, that's 3. And 3 definitely goes into 3. So I know that is divisible by 3. And the sum of these digits is 5. and 3 is not divisible by 5, or 5 is not a multiple of 3, however you want to think about it. So you actually add up each individual digit to figure out if it's divisible by 3. It's interesting. It's a neat rule for divisibility. All right, let's do divisible by 9. A number is divisible by 9 if the sum of its digits is divisible by 9. And we're going to do some examples. Let's just get these all down. All right. Divisibility by 4 is a neat one too. So a number is divisible by 4 if the last two numbers are divisible by 4. Okay, I'll let you get that down, and then we'll look at it. So a number is divisible by 4 if the last two digits of the number are divisible by 4. Okay, I'm going to give you a couple. Are you ready? 1,222, 1,220, 1,224, and 1,226. All right, so all you have to do is look at the last two numbers. Does 4 go into 22 evenly? Nope, so 4 is not a factor. Does 4 go into 20 evenly? Yep, so this number is divisible by 4, so 4 is a factor of that number. Does 4 go into 24 evenly? Yep, so this number is divisible by 4, or 4 is a factor of the number. And does 4 go into 26 evenly? No. So 4 is not a factor, or 4 is not, or this number is not divisible by 4, however you want to think about it. So you're just looking at the last two numbers. It's interesting. That's an interesting one. All right. 6. A number is divisible by 6 if the number is divisible by 2, so if the number is even, and if the number is divisible by 3. So if it's divisible by 2 and divisible by 3, then you know that it's also divisible by 6. Okay? And the last one, a number is divisible by excuse me, is divisible by 12 if the number is divisible by both 3 and 4. Oh, excuse me. Excuse me. Sorry, this is unedited, so you're catching my sneeze. Okay, so let's try this. You ready? So I'm going to write a number. Let's see, let me think which one I want it to be. Let's make it, how about 1, 2, 3, 4, 5, 6. There we go. I just made that up. And then 2, 3, 4, 5, 6, 9, 10, and 12. So I want to know which of these numbers will divide evenly into 123,456. Okay? No calculator. No calculator. Okay. Will 2 go into it? You would say yes. It is divisible by 2 because this number is even. All right, let's add up the digits. So we have 10, 21, right? 10, 21. Okay, so is it divisible by 3? You're going to say yes, it's divisible by 3. By 3 because the sum of its digits is 21, and 21 is divisible by 3. So that's how you're going to answer the questions on your WOW. All right. Does that make sense, I hope? All right, let's try 56. So with 56, you just look at the last 2 digits. So is 56 divisible by 4? Yeah, it looks like it is. So you would say yes. This number is divisible by 4 because the last 2 digits is divisible by 4. Is it divisible by 5? You would say no. It's not divisible by 5 because it does not end with a 0 or a 5. Is it divisible by 6? You would say yes, it's divisible by 6 because it's divisible by both 2 and 3. All right? Is it divisible by 9? You would say no, because the sum of its digits is 21, and 21 is not divisible by 9. Okay? Is it divisible by 10? You would say no, it is not divisible by 10 because it does not end with a 0. And then with 12, you have to be careful. It's divisible by 12 because it's divisible by both 3 and 4. Not 2 and 6. It's divisible by 12 because it's divisible by both 3 and 4. Okay, I hope those make sense. I feel like we should try another one. Let's try one more. All right, how about, I'm just making one up. Let's hope it has something. How about we go all the way? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 123,456,789. Let's hope one of these works. I don't know. 2, 3, 4, 5, 6, 7, 8. Nope, not 8. She's not 7. 9, 10, and 12. 2, 3, 4, 5, 6, 9, 10, and 12. And I wish we were at school because Luke, my 5th grade, when he was in 5th grade, had the cutest book, and it's in my office, of course, with everything else in the world. And the teacher made a book, so they folded up a bunch of paper like this. They took paper, and she stapled it. And then Luke wrote I think it was called My Rules for Divisibility. It was the cutest thing. It was in 5th grade. And then each page had a dedication to a divisibility rule. So I know they're covering this in 5th grade because he had the cutest little book that he made. But of course I can't show it to you because it's in my office. All right, so here we go. Is it divisible by 2? You would say no, it is not divisible by 2 because the number is even. Or is not even. It ends with a 9, so the number's not even. All right, is it divisible by 3? We've got 10, 20, 30, 45, right? 10, 20, 30, 45. So yeah, you would say yes, it's divisible by 3. It's divisible by 3 because the sum of its digits is 45, right? 45 divided by 15 is 3, is 45, and 45 is divisible by 3. All right, is it divisible by 4? No. First of all, it's not even, but the last 2 digits are not divisible by 4, right? It has to be even for it to be divisible by 4. It's not divisible by 5 because it doesn't end with a 0 or 5. It's not divisible by 6 because it's not divisible by 2, right? In order for it to be divisible by 6, it has to be divisible by 2 and 3. It's divisible by 9. Yes. It is divisible by 9 because the sum of its digits is 45. And 45 is divisible by 9. So it is divisible by 9. Interesting. So far we have it's divisible by 3 and 9. It's not divisible by 10 because it doesn't end with a 0. And it's not divisible by 12 because it's not divisible by 4. In order for it to be divisible by 12, it has to be divisible by both 3 and 4. All right, I hope that that is enough examples. You have some of those on your OWOW, so make sure you read the OWOW carefully because you got to get back to me on a time that you want to take the test, right? So Zoom me at some point this week. I'll be on Zoom at those times that I designated on the OWOW. And then now you have these rules for divisibility to answer that question. All right, so I'm going to make one more video after this one. It will be much shorter, but it's how to determine if a number is prime. All right, and so we'll have this one and be done with section 4.2. All right, so tune in to the next video.